Now let's look at how we can move files. And the command for moving a file to a particular location is called mv. And suppose I'm gonna create a new file and also a new directory. Let's make a dir. Let's use -p. I'm gonna make a make a directory that's called temp, and underneath temp I'm gonna make another directory called test, a subdirectory underneath temp, and I'm using -p option because the parent directory of test, which is temp, does not exist in my home directory at this moment. So by using -p, it's going to create the parent directory of test also. So if you look at my directory now, it has a temp, and if you look into temp, and then there's a subdirectory called test. So I'm going to make an empty file called abc1, suppose. So now I have an empty file abc1, and then I'm going to move it to the test subdirectory inside temp. So I'm going to use move abc1, and then followed by the destination folder actually. So it's temp test. Now abc1 has disappeared from my home directory, but it should exist now underneath temp test, and you can see it's there. So basically that's it's the basic way for using the move mv command to move a file to a specific location. Now suppose I remove the test subdirectory. I'm gonna rmrf. I'm gonna remove the test subdirectory underneath temp, including the abc1 file. I'm gonna remove it. So underneath temp there's nothing for now. I'm gonna generate the empty file abc1 on my home directory. Now let's retype the move command. Let's move abc1 again to temp test. Exactly the same command as we have typed before. I typed the same command here. But when I typed this command, there is a subdirectory called test that's underneath temp. But when I typed this command, the same command now, the test subdirectory on the temp does not exist. So if I do this command, let's see what's going to happen. Of course, abc1 is going to disappear under my home directory, but where it is now, let's look into temp. Now temp, underneath temp, there's a new file called test, and this test is a file instead of directory. It's not a subdirectory, but it's a file. So what has happened is that the move command has moved abc1 to a file called test underneath temp. So essentially what move has done is that it has renamed the file abc1 to a different name, which is test underneath temp. So basically you can use move command mv to both move a file and also for rename a file, for example. So let me delete. I'm gonna delete the temp directory, including all the stuff that's inside of temp. Now let's touch abc1, touch abc2. I'm gonna touch two files. So I'm gonna echo a text strings test 1 2 3. I'm gonna echo this into abc1. So last time I mentioned this is called a redirection. So it's basically echoing this particular text string. Instead of to the screen, to the terminal, it's echoing it into a empty file. So now if you look at, we're gonna look at how to look at the content of a text file later on. It's called cat abc1. Then it's gonna tell you the content of this particular file is has stuff in it. Now let's try to move abc1 to a different name. So I'm going to try to rename abc1. I'm going to rename it to abc3. Now if you look at my home directory, there's no abc1 anymore. abc1 has disappeared. But instead I have an abc3, and the content in abc3 should be exactly the same as abc1. Test 1 2 3, that was the text string that I echoed into abc1. So you can use move mv to change the name of a particular file. Now let's try to move ABC3 to ABC2. ABC2 for now. ABC2 is an empty file. If you do cat ABC2, there's nothing in it. It's an empty file. You can do a long list of ABC star, ABC question mark, wildcard. So ABC2 has a size of 0, but ABC3 has a size of 11. Now let's try to move ABC3 into ABC2. I'm trying to rename ABC3 to ABC2, but ABC2 already exists and it's an empty file. But let's see what's going to happen. And then it's going to ask me, do I really want to overwrite ABC2? For now, let's just answer yes. And then if we do ls again, there's no ABC3 anymore. It's just ABC2. Now the content of ABC2 should be test123. If you do cat ABC2, there's test123 because it was renamed from ABC3, and ABC3 has a content that's test123 in it. So let me generate a new empty file. This is called ABC1. Suppose I'm gonna touch ABC1, and now I have two files. One empty, ABC1 is empty. ABC2 has 11 bytes in it. So now let's look at the move command, mv command. Why it's sort of asking me this particular, do I really want to override, right? Because this is the default behavior. Let's type mv and see if it is an alias. Yes, indeed, it is an alias, and it's aliased to mv-i. -i means interactive. We talked about -i, this option, when we were talking about how to delete files, rm command. The rm command. So -i means interactive. So mv is also interactive. It's aliased to mv-i, so it's also interactive. The default behavior for mv alias is sort of interactive. It's gonna ask you for confirmation. So if you want to unalias it, you can unalias mv, and then if you do type mv, it's gonna say it's hashed being mv. But now let's try to mv. Let's use the -i explicitly. ABC2, ABC1. Then it's gonna ask you if I want to overwrite. If I say no, say no, and then the rename is not gonna happen. It's not gonna happen. So let's alias it back. Let's alias mv equals to mv-i. Let's still define the alias. But suppose you want to override this -i option that's already embedded into this particular alias. You can use another option. It's called -f. So -f means force. You are forcing this rename. And if you use -f, it's gonna cancel out the effect of -i. So if you do -f ABC2, ABC1, then it's not gonna ask you for confirmation. And then if you look now, there's only one file, that's ABC1, which has 11 bytes in it, and it's because it's renamed from ABC2. Now let's again generate a new file called ABC2. Now we have two files. One is generated at 13 o'clock 35 minutes, and the other one is generated at 13 o'clock 40 minutes. So one is earlier than the other one. ABC1 is earlier than ABC2. ABC2 is later than ABC1. Now let's try a new option that's called -u. U means update. So it's gonna copy only when ABC2. It's gonna so let's try some command. ABC2, ABC1. No, let's try the opposite way. ABC1, ABC2 first. Let's try this, because we know that ABC1 is older than ABC2, and -u means update. So the behavior is that if ABC1, if the source is older than the target, then the move command is not gonna execute it. So let's give it a try. So you still have two files, abc1 and abc2, because you use the -u command, -u option. So the move is going to happen only when the target is older than the source. But for this kind of situation, the target is actually newer than the source. So -u will actually make sure that the move will not happen actually. So, but if I switch the role of the source and the target, because I know that now the source abc2 is actually older or newer than abc1, the older file, then this update is going to happen. So it's actually asking me, do I want to override abc1? If I say yes, then this update is going to happen. Now you have only one file and it's empty because you have moved the empty file abc2, that's the source, to the target. So for the move command, you have -I, which is going to enforce the interaction, ask for confirmation before actually override something. You also have the -u option that's going to update or move the source to the target only when the source is newer than the target. You can also try to move an entire directory. Suppose I'm going to create a new directory that's called I'm going to create two directories called temp test1, temp test2. So now underneath temp I have two different directories. So suppose I move abc1 into the abc1 is under my current directory, home directory. I'm going to move it to temp test1. Now if I look into both directories, I have abc1 that's under temp test1, and then temp test2 is empty. There's nothing in temp test2. Suppose I move temp test1. I'm going to move it to temp test2, and let's see what's going to happen. Now there's no test1 underneath temp anymore. There's only test2. But what's actually inside of test2? You have another directory that's called test1. And then if you look into test1 again, that's abc1. So now you have a nested directory that's test1 underneath test2, and then test2 underneath temp. But suppose let's go inside of a temp, and then let's move test2 test1 to the so dot means current directory, and my current directory is the temp directory underneath my home. So now again I have recovered the original directory structure, that's test1 and test2 underneath temp. So now let's remove the test2. Let's remove test2. But since it's a directory, so I have to use -r. But if I want to force it, no, sorry, test2. So now there's only test1. But suppose I want to move the entire test1 to a different name. For example, I want to rename it to test2. I can just do that. Now test1 disappeared, but I have test2. And if you look into test2, it has exactly the same content as test1 before. But this time test1 is not a subdirectory of test2 anymore. This time test1 has been renamed to test2. And the content inside of the test2 now is exactly the same as the content inside of test1 before. The reason that this happens is because test2 doesn't exist. Test2 doesn't exist. It's not an existing directory because I did this removal. I deleted test2 in this particular command. So when I do mv, when I move test1 to a non-existent name, test2, then it's just going to rename test1. Now let's look at how we can copy files. The command for making a copy of a file is called cp. So you can just type cp, and then followed by the source file, and then followed by the destination file. So let's do some experiment. I'm going to remove So I'm gonna touch two files, two empty files, abc1 and abc2, and then I'm gonna make a directory called -p test1. So if I want to copy the abc1 from my home directory to temp test1, what I can do is to do cp abc1 and then temp test1. If you look into my home directory, abc1 still exists, so it's different from move. And if you look into temp test1, it's gonna have another copy of abc1. And you can copy a file and rename it at the same time. So suppose I do a copy abc1, but I want to copy it to test1, but I want to change the name to a different name. Suppose I call it abc3, for example. Now if you look into temp test1, you're going to have two files. One is abc1, the other one is abc3. So it's making a copy of abc1 and then it's copying abc1 to temp test1 and then change the file name to abc3. So now you have two files, but both files are actually identical to abc1. So this is how we can copy a file. Suppose we want to copy a directory. So underneath temp we have test1, this directory, and the command for copying a directory is called cp-r. The R option means recursive. So what you can do is to copy test1 to temp, and then a different directory, say test2. And then if you look into temp, you're going to get two directories, test1 and test2. And if you look into test2, if you look into temp test2, it's going to have exactly the same files as test1. So now let's try to change the files. Let's try to change the files, and we're going to try a different option called -u. First, let's echo some text string. I'm going to echo test123 into temp test1 abc1, and then I'm going to echo test 456 into temp test2 but abc3. Now let's do a long list of temp test. I'm using a wildcard, and then wildcard behind the test means that I want to list the content in both test1 and test2, and then followed by star. Star means I want to list every file underneath these two subdirectories. So I'm going to see the files that I have generated. So temp test1 abc1 has non-zero size, and it was generated at 1412. And temp test1 abc3 has zero size, and it was generated at 1411. And then temp test2 abc1 has zero size. It was generated at 1412, and then temp test2 abc3 was generated at 1412, and it has non-zero size. Now let's use the -u option, update. Let's cp. We're going to use R because it's an let's just use -u, and then temp test1. I'm going to use star everything, and then to temp test2, and then let's see what's going to happen. So it's telling you that it's going to override temp test2 abc1. It's going to override temp test2 abc1. The reason it's doing the override was that temp test1 abc1 was changed later. So this file actually has a later date or later time. Last time I touched it, the last time I changed it was later than this particular file. So this file is actually newer than this file, and it's actually telling me that it's going to overwrite this old abc1 using the newer abc1. I'll say yes, and then that's it. It's not actually promoting. It's not actually asking me to overwrite abc3 on the test2. The reason is that this abc3 on the test2 is actually newer than abc1 on the abc3 on the test1. So it's not doing the update for abc3. So that's the -u option, and you can actually use the -u option to update the files. So it's going to copy or overwrite. It's going to override or copy only when the source file is newer than the destination file. Of course, you can also force the copy, so you don't really have to sort of go into the interactive mode and answer yes or no, and you can just use cp -u f and force the overwrite, so you don't really have to sort of answer yes or no every time it has to do an overwrite. And there's one more option that's quite useful. That's called parent. That's dash parent actually. Uh, so suppose you wanna copy the entire directory temp into some kind of a backup directory. So I'm gonna make another directory. I'm gonna make another directory called backup. So backup, which is here. There's nothing in it. Suppose I want to backup my test1 directory underneath temp. Suppose I do cpr temp test1. I'm gonna copy it into backup. Now if I look into backup, there's gonna be a test1 in it, and the stuff that's inside of test1. Now suppose I want to copy test2 also into backup, but this time I'm gonna use parents --parents and then -r because I'm copying a directory. But I'm gonna copy temp test2 into backup. And then let's look at what's inside of backup. Inside of backup, you have test1. That was what I copied before. And then you have a directory called temp instead of test2. And if you look into temp, you have test2. And then if you look into test2, it has the exact same content as the test2 underneath temp. So if you actually use --parents, it's going to copy not just the directory that you intend to copy, but also it's going to copy all the paths, the entire path of the directory that you are copying into backup, into this destination folder. So suppose I want to copy test2, but this time I'm going to use the absolute path of test2. cp -parents -r, and then I'm going to use my absolute path. I'm also copying it into backup. Now let's look into backup. Now you have not just the temp, you also have the home. And then if we look into backup home, and then you have pochen, that's my home directory, and then you have temp, and then you have test2. So it's basically the --parents option basically allows you to keep the information about where the files were originally stored. So the entire path will copied over for every file. By looking at the path, you know the origin of that particular file, not just the file contents, but also where the file was originally stored. In addition to making copies of files, you can also make links of a file. So Linux actually allows you to link several files together by using the ln command. So ln actually represents link. There are two types of link. One is called a hard link. The other one is called a symbolic link or symlink. So a symlink is also called a soft link. So the difference between these two types of links is that the hard link is basically an alias of the same file. So if you create a hard link of a certain file, both the original file and the hard link will share exactly the same content, will share exactly the same attributes, properties. So if you modify one of the file, either the hard link or the original file, both of them are going to change at the same time. So a soft link uh, is a redirection to the real file. So you can the the hard link is a way to backup file on the same disk. The soft link or symlink just allows the file to appear to be in a different location. So let's try to do some examples. For example, uh, I'm in my home directory. Let's try to create a some file. Let's just touch abc1. It's an empty file, and let me put some text into it. Test 1, 2, 3. If I do a long listing, I can see both the attributes and the size of the file. It's 11 bytes. So if I create a hard link using the ln command, so basically the syntax is that you link something to something else. So you can create a link. Let's call it lnk1. Now this is gonna create a hard link. So if you do ls l*1, then it's gonna show you the the the, the properties and the size of both files abc1 and link1. So their attributes are exactly the same, and then the size are exactly the same. And if you look at the content of link1, let's just use cat link1. It also has the content test 1, 2, 3. And then if you try to change abc1, for example, suppose I echo test 4, 5, 6 into abc1. So again, I'm using the redirect symbol, redirect mark. So I'm gonna echo test 4, 5, 6 into abc1. So it's gonna overwrite the original content in abc1. So if I do cat abc1, now the content is test 4, 5, 6. And then if I do cat link1, the content also has changed to test 4, 5, 6. So if you change just one of the files, it's gonna change the other file also. So if I do echo test 1, 2, 3, I'm gonna overwrite the hard link this time. I'm gonna overwrite the content of the hard link this time. So if I do cat link1, now it's going back to test 1, 2, 3. And then if I do cat abc1, it's gonna go back to test 1, 2, 3 again. And inside of this in this long listing, if you look at the second column, just the column after the attributes, now it's a 2. So when you are listing ls, when I did the long listing of abc1, the second column is 1, and now the second column has turned into 2. So what I was telling you when I was explaining ls -l, this long listing command, the second column actually indicates how many hard links exist to this particular file. So now you have created a hard link, and the second column has turned into 2. And so that's a hard link. And you don't really have to sort of link it to a link at the present directory or current directory. Suppose I make a directory temp test. I'm gonna use -p because the temp directory doesn't exist. And then I can just link ln abc1 to temp test lnk2. Now if you do a long listing abc *1 and then temp test k2, you're gonna see you have 3 files that have exactly the same attributes, exactly the same size, and now the second column has turned into 3. So the second column is gonna keep counting how many hard links exist to this particular file. And if you want to look at the content of temp test lnk, it's test 1 to 3. So that's hard link. Now let's try to use the soft link And the soft link can be created by using the -s option. So if I want to create a soft link, so ABC1, the target is ABC1. I want to create a soft link, for example, link 3. And then let's try to make a long listing. I'll just use ABC1 NK. So what you can see is that there's a hard link. That I created before, and then this is actually the soft link that I just created, and it has a property. The first letter in its property, in its attribute, is L. L means link, and then the size of it is 4. The size of the link itself is 4, and then it points to the file ABC1. So this is actually the size of the link itself. It's not the size of the target file. And as you can see, if you create a soft link or symbolic link, the second column, the number in the second column of the long listing doesn't change. It's still 3, because we have created 2 hard links, and then the 2 hard links, link LNK1, and the other one is under what? The other one is temp test LNK2. So these are the 3 hard links. These two are the 2 hard links, and then that's the original file, the target. So you still have like the second column is still 3. Soft link doesn't change the second column. So if you would like to take a look at the content of LNK3, it's going to display the content of ABC1. So every read or write that you issue to the soft link it's going to be redirected to the target file. So if I want to echo a different command, echo test 4, 5, 6, if I want to overwrite the content of link 3, and then if I do a cat lnk3, it's gonna change the content has changed. And then if you do cat abc1, the content has changed also. So the soft link is just another sort of alias to the target file, and you can change. If you change the target file and then read the soft link, it's gonna redirect to the target file, so it's gonna display the changed text content of the target file. Now, there's one common mistake that people often make. Now let's try to make another soft link. So LNS ABC1. The target is still ABC1, but I'm gonna put the link into temp test. So I'm gonna do temp test. That's my link. LNK. Let's do 4. So the syntax looks quite correct, right? Last time when we made the symbolic link, it was on this line. I was doing a ln-s abc1 and then link 3, and then here I'm just changing the location of the soft link to a subdirectory, to inside of a subdirectory of temp. So now if you look at lsl abc1 lnk and then temp test star, so you're gonna see 2 symbolic links, abc link 3 starting with the L, so it's a symbolic link, soft link to abc1, and then you have a temp test link 4 that's also pointing to abc1. Does that look right? It looks correct, but if I want to look at the content of temp test lnk4, it's gonna give me this error message: no such file directory. If you look at what this link is pointing to, it's pointing to abc1, but without any path or prefix that's in front of abc1. So what it's actually is it pointing to? It's actually pointing to abc1 that's under temp test. So this link is actually pointing to a non-existent file, because on the temp test you don't have a file that's called abc1. So this target it's pointing to is actually referenced to the parent directory of the link. So if you actually go if you go into temp test and then do an ls, you see link 2 and link 4, but you don't see a file that's called abc1. So how do you actually make link 4 work? So let me go back to my home directory. So now let's overwrite the previous link and using the -f. So -f means force. You're forcing a relink, so it can be combined with -s. So I'm not gonna not gonna change the location of the link 4. So it's still gonna be inside of test on the temp. But what I'm supposed to change is to give ABC1 the target, to give the target a a more complete path. So suppose I change it to dot slash. Dot means the current path, my current path in my home directory. So dot slash abc1 actually is my uh, actually points to abc1 on my current directory, on my home directory. And then let's see if it's gonna work. Again, let's do a long listing of temp test star. So now temp test link 4 actually points to dot slash abc1. So if you do cat temp test link 4, it's still going to give you no such file directory. So this dot actually references to temp test. It's not referencing to my home directory. So what can you do? What can you do now? So let's again change my syntax. SF. Instead of using a dot, I can use the wiggle. Wiggle is a shorthand for my home directory. And then temp test link4. So now if you do a long listing, now you can see temp test link 4 now points to an absolute path and abc1 with the absolute path. So now if you do cat temp test link 4, it's going to show you the correct content. And you can delete links just like you delete files. You can use rm to delete a link. Suppose I want to delete temp. Suppose I'm going to delete the entire directory of temp, including all the links that's inside of the subdirectory test. And then let's see what's going to happen in my home directory. So the original file, the target file, is still there. So by deleting the link, either hard link or soft link, you're not going to delete the target file, the source file. So if I delete link 1, link 3, so you don't see the links anymore, but the original file is still there. And if you want to look at the content of it, it's not changed in any way. Now let's look at how we can sort of display the content of a text file. We're going to look at the 3 commands: head, tail, and cat. So head is going to display the command head. It's going to display the first, by default, it's going to display the first 10 lines in a particular text file. Suppose we would like to display the first 10 lines of a text file that's on the PROC. Let's call it mem.info. Mem.info. This particular text file stores information about the memory usage at on the current machine at the current state. So it's going to display the total amount of memory, amount of free memory, all those useful information. It's basically the top 10 lines inside of this mem.info text file. So if you would like to see more lines, you can use the -n option. Suppose I want to see 15 lines instead of just 10 lines, and then you can just follow it by the name of the text file. Then it's going to display 5 more lines. So you can basically follow the number of lines, follow -n with the number of lines you want to see, and then you can just display the text, display the number of lines in this particular text file. Now suppose I want to Suppose I want to display multiple text files. I want to display the head of multiple files. I'm going to display PLC every file that starts with M, the letter M. So if I do this, then it's going to print out the first 10 lines, of all the text files on the PLC that starts with M. So the first file it's going to display, the first file it was displaying is the top 10 lines of mdstat, and then that's the next file, that's minfo, and then that's the next file, misc. So it's actually appending, it's actually adding the file name in front of the text of the content of that particular text file. So if you would like to use a wildcard and display the heads of multiple text files in just one command, you can just head and then use a wildcard. But suppose you would like to display those the heads of multiple files without displaying the file name in front of the content. There's an option that's called quiet. It's called -q. So -q means quiet. And this time, let me clear out the screen. And if you use the quiet option, -q, then it's going to suppress the printout of the file name. Now you don't see the file name anymore. And it's just the first 10 lines in each of the file that starts with an M. They just concatenate them together without displaying the file names. So basically that's head. And then you also have another command called tail. So tail is going to display by default the last 10 lines in a text file. Suppose you want to display the last 10 lines in meminfo, then it's just going to print out the last 10 lines. Again, it also takes -n option and then followed by the number of lines you want to see. So it's going to display more lines this time. The tail command has also the quiet option. Suppose you want to display use a wildcard. If you want to use a wildcard and then display multiple files, the tail of multiple files, it's going to print out the file name in front of the content. So if you want to suppress this file name printout, you can use the -q. If you would like to repeat the previous command, you can just use the arrow key up, and then it's gonna in the terminal, and then it's gonna repeat the command that you just typed. If you use the -q quiet option, then it's gonna suppress the printout of the file name. The tail command also has one additional option that's called -f. Suppose I would like to follow the printout, the tail of a particular file, that's a particular text file that keeps updating. Suppose I would like to display this particular output file. This particular text file is still changing because I'm running some kind of simulations on a cluster, and the printout, the output of that simulation is stored into this particular output file. And because the simulation is still running, so the output is still there's still new output being generated. And if I use -f, f here means follow. It doesn't mean false. It means follow. So it's gonna keep updating. It's gonna keep updating the tail of that particular output file every time it's the output file actually changes. So as you can see, the time step keeps increasing because my simulation is still sort of calculating the time history. So if you want to quit the following mode, you can just use Control-C. Hold down the Control key, CTRL key, hold down it, and then type C. Then it's gonna jump out of the following mode. So that's basically head and tail. And then you also have cat. Cat is command for you to display the entire content of a particular file. So if you do cat proc minfo, it's going to display the entire content. So for this particular text file, it's not too long, so I can still use my scroller to go up and down to look at the content of this particular text file. But suppose you have a very large, very long text file, then if you do cat, it's just gonna scroll over the entire screen very quickly. You won't be able to read the content of the text. So if that's the case, there's another thing that you can do, which is pipe it through another command called more. So we're going to talk about how to connect commands together using a pipe. So this vertical bar actually means a pipe, and then cat is a command for displaying the content, and then more is another command that allows you to page through the content. So now it's just displaying the beginning part of the text file, and then without scrolling through the entire file, and it's actually waiting for you to type a space. If you press space at this point, it's going to flip to the next page. So we're going to talk about how to connect commands together using a pipe later on. But now cat is just one command that allows you to display the entire content of a particular text file. A better way to view the content of a very long text file is to use the command less, or less. Use the command less. Suppose I wanna let me do a listing, but at this time I'm going to use -a, so I can see the hidden files. Suppose I would like to look at the content of .bashrc. So I'm going to use less .bashrc. So it's going to page through the entire text file, and you can use the space key to go down one page, or use the arrow key, keyboard arrow key, to navigate to go up and down one line at a time. Or you can use the page up and page down key on your keyboard to go up and down one page at a time. And it has a prompt colon, so it actually allows you to enter particular commands. So if you would like to quit less, you can just type Q, and then it's going to go back to the shell. And this less command actually takes lots of options, takes a lot of options. We're going to look at two options. That's big dash capital M .bashrc, and this time it's gonna display some additional information about where you are inside of this text file. So it's showing you the name of the file that you are looking at, and then line number from 1 to 24 that I'm looking at, and then out of 82, so the entire file has 82 lines, and then I'm looking at about 22% of the entire file. So if I go use the arrow key to navigate down, it's going to change, the line number is going to change, and then percentage is going to change. So -m is going to give you, capital M is going to give you this particular information line. And then there's another option that's quite useful, that's capital N. So capital M means line number, so it's going to number all the different lines. So I can combine these two options together, capital M, capital N. And this time it's going to number all the different lines inside of this text file. And again, you can use the arrow key, page up, page down key to navigate inside of this text file. And suppose you would like to go to a particular line. Suppose I want to go to line 50. So suppose I can on the keyboard I can just type the number 50, and then followed by the letter G, and then it's going to jump to the 50th line inside of this text file. Suppose I want to, so this line 50 is actually at 89% of the entire file. So if I want to go to 50% of the entire file, I can type 50 on the keyboard, and then followed by the letter P as in percent, and then it's going to jump to about 50% of the text file. And that's some commands for you to navigate through the text file. And then there's a command that's called search. That's the slash key, the slash on the keyboard. And suppose if you would like to search for a particular string, that's capital SAC, you can enter the particular string, and then it's going to highlight all the occurrences of this particular string for you. And if you would like to search from the back, from the end of the file, you can use the question mark. And then suppose I would like to search for CUDA, C-U-D-A. And then it's going to start from the end of the text file and then go backwards and highlight all the occurrences of this particular text string CUDA. And if you want to turn off the highlight, you can use the ESC key followed by U. Press the ESC key, the escape key once, and then type the letter U, and then it's going to turn off the highlight. And and then we can just, if you want to quit, just type the letter Q. And in the command line, in the less command, there's also an option that's a plus sign. That's the plus sign. And then you can follow the plus sign with any command that you would like to use inside of less. Suppose I want to go to line 50. So when I open the .bash rc, this text file, I wanted to go directly to line 50. Then I can, using the plus sign, and then followed by 50g. 50g is the command that I would have typed inside of the less. And then you can just use this command to start less, and then it's going to jump directly to line 50. As you can see, it's jumping directly to line 50. Or you can just use some kind of search. Suppose I want to search sec. You can also follow a search command. You follow the plus sign with the search command, and then it's going to jump directly to the first occurrence of this particular string from the beginning of the text file. Of course, you can also search from the back of the file. And then it's going to jump to the first occurrence to the string that you are searching from the end of the file. So that's less. The less command also allows you to view the content of multiple text files. Suppose I would like to display to view the content of this file .bash rc and also this file .emacs. So I can do less .bashrc and then .emacs. I'm viewing the two files. Suppose I would like to use the option -m and then it's going to display this the information for the first file, and then it's going to tell you that this is file 1 of 2. So you are actually opening two files, and you are actually viewing the first file of the two files. And if you would like to jump to the next file, the command that you have to type inside of the less is first type the colon, and it's going to give you the command, the prompt, the colon prompt, and then type the letter N. Now it's going to take you to the second file. So it's showing you the name of the file .emacs, and then it's telling you it's file 2 of 2. It's the second file. And then if you would like to go to the previous file, then you do colon again and then type letter P, and then it's going to go back to the previous file. So you can actually jump back and forth and look at multiple files in just in the less command. Now let's still try the opening the two files, but this time inside of less I'm going to open another file that's called a .bash profile. Inside of the less I'm going to open this file in addition to these two files, but I'm putting the file name of these two files on the command line. So now I'm looking at the first file of 2. So I'm looking at .bashrc. Now if I want to look at the .bash profile, what I can do is to type colon and then followed by E. So it's actually telling me I want to examine what. It's asking me to type the file name. I'm going to type the file name .bash profile. Press return, and then it's gonna tell me that now I'm actually looking at .bash profile underscore profile. That's file 2 of 3. So now inside of less, I'm opening 3 files, and I'm looking at the second file of the 3 files. If I want to go to the previous file, it's telling me it's .bashrc. If I want to go to the next file, then it's .bash profile. The next one again, then it's .emacs. So now I'm jumping back to .bashrc. So I'm actually have 3 files open inside less. Now suppose I want to do a search. I want to search for sec, but I want to search through, not by default. Less is going to search just in the current file. That's .bashrc. But if you actually follow the search pattern with the wildcard star, and then it's going to search through all files. Now press return. So now it's inside of the sec, inside of the .bashrc. Now this is inside .bash profile, and then it's also displaying all the occurrences of this search pattern. And then if you want to go to the next file, and again, but this file doesn't have any occurrences of sec. So if you want to go to the previous, it has some occurrences of sec. If you want to go to previous again, it has some occurrences of sec. And then less also allows you to go to the shell inside of the this interface. So if you just type the exclamation, and then followed by the command that you would like to sort of execute, for example, ls, suppose, then it's gonna execute the ls command, and then gets back to you with a prompt that's done. And then at this stage you can type enter or return, and it's gonna go back to the viewing interface. So exclamation point allows you to go to the shell. So if I just type exclamation mark, and then return, and then it's gonna give me the shell. I can do an ls. I can do ls, do a long listing, and then to look at my the content of my directory. And then if I'm done with the shell, I can type exit. Then it's telling me done again, and then asks me to press return. Again, I'm going back to the viewing interface. So the exclamation point itself with a return allows you to go to the shell, and you can also access the shell by using exclamation mark followed by the command that you would like to execute inside of the shell. Okay. Now suppose I would like to go to the now I have 3 files open. Suppose I would like to delete the last file from not deleting it from the file system, but removing the last file .emacs from less. I don't want to view the content of .emacs anymore. So what you can do is to use colon again, and then type the letter D. Now you have 2 files, and you are looking at the file 2 of 2. You are looking at the second file. So if you would like to go back to the previous file, it's displaying .bashrc. If you want to go to the next file, it's displaying .bash profile. Now you don't see .emacs anymore. Emacs is still in there, but it's just not being viewed by less.